So the first one is convection current density. So conduction current, you all know, it is the current flowing through any conductor, so which will obey Ohm's law. Whereas in convection current, the current is not flowing through a conductor, whereas it is flowing through a dielectric medium. This dielectric medium or insulating medium, it may be a liquid or a rarefied gas or even vacuum. Example of convection current is a current that is or a beam of electrons which is flowing through a vacuum tube. Okay. So in order to derive the expression for convection current density, you may consider a volume, closed surface, or a volume like this. Okay. You can see the length of the small elementary surface, closed surface, you have considered is delta L. It is having a cross-sectional area. This is the cross-sectional area that is having an area delta S. Okay, and you are considering a volume charge density. Okay, the current that is flowing through this closed volume is having a volume charge density rho V, and you are assuming that the electrons are moving with a velocity uy. Uy is indicating that it is flowing along the y direction with a velocity u. So you can write the velocity u is equal to ay into ay. Ay is the magnitude here, and unit vector ay is indicating that it is flowing along the y direction. So the net current flowing through the small elementary surface delta I is equal to delta Q by delta T. We know current is the rate of change of charge. So delta Q by delta T. Now if rho V is a volume charge density, charge flowing through the small elementary surface delta S will be delta V into the elementary volume. Elementary volume is obtained by multiplying length into area. So delta S into delta L, okay, divided by delta T. Now a small rearrangement is done, and so you are taking this delta S outside. So rho V into delta S into delta L by delta T. What is length by time? It is your velocity uy. Okay, so rho V into delta S into uy. Okay. Now the current density you can obtain. Okay. Now you have current formula delta I is equal to rho V into delta S into uy. So by taking this delta S to the LHS, that is you are getting delta I by delta S. That is nothing but your current density in the y direction. That is equal to what remains is the RHS is rho V into uy. Hence convection current density is given by the expression J is equal to rho V into U, and it is having a unit ampere per meter square.